All right, welcome. My name is Hannes, and I'm speaking today about building flexible software. Now, I suspect that a lot of you are here because in my title I disrespected Lego a little bit, and if there's one thing you shouldn't do with developers, then it is just that. Let me tell you, I think Lego is awesome. My kids play with it all the time. I play with my kids. So I play with Lego all the time. But we also like to build marble tracks, and that's also cool. So just lower your pitchforks, okay? I don't mean any disrespect. But I didn't want to hold out this picture from you guys because totally coincidental. I didn't push them in any way, but my two sons, they built this like a little over a week ago. They used a lot of Lego bricks to make pillars for their marble trick, and I was like, I gotta get a picture of this for my talk. Second disclaimer, I will not be talking about any fancy frameworks or hipster libraries or the other way around. I'll just be talking about code structure. So if you came to the right talk, there will be a service announcement after this, so you can just walk out, okay? Service announcement. You should not be saying Legos. Lego is a brand name, and you use it as an adjective. So you can say Lego set or Lego brick or whatever, but you cannot use the plural Legos. You piss off Lego people if you do that, so don't. Okay? Now to the main story. What were we working on at the moment that I built the proof of concept that led to today's talk? I was working for a company, and they were building a huge platform to manage IoT devices. And it had a lot of core functionality, but it also had a lot of implementations. We supported a lot of different types of devices. And new types of devices, they arrived all the time. And they all had some core functionality that they shared, and then there was some specific stuff for every device type. And everything was deployed in one huge multi-tenant platform. So it wasn't like we're going to deploy two device types for customer A and then some for another. No, everything was deployed together. And to make you also understand why we did what we did, you also have to understand what type of company we were in. We were doing new device type implementations pretty much all the time. That was the main part of what we did. But we did these for potential new collaborations with device suppliers or other customers. So we used to do all these implementations. And then our product management, and you will surely be able to relate to this, they felt like they had invested a lot of money in these. So even if the project didn't go live, we didn't throw away the code. It's like, you keep that for a later date. But yeah, you know how that goes with a code base like this. You have to also maintain that code. So it ends up costing way more money in the long run, even if you keep it. So that was kind of a maintenance hell that us developers really wanted to move away from. We wanted to have a better way to deal with this. And this is a very famous quote by Ken Thompson. One of my most productive days was throwing away 1,000 lines of code. And that's really how I felt. I wanted to do that every day, and I couldn't. And my two sons, they would disagree about which one of these two you need, because one of them has his favorite color green, the other one's yellow. So total coincidence that I found these two. But you need this. You need to be able to part with your code if you're no longer using it. But that was easier said than done, because product management wasn't ready to change. So we were going to keep doing new implementations. Whatever we did, that was going to keep happening. And they had as a fixed requirement from us that we needed to be able to resurrect that code whenever we needed it. Sound familiar to any of you? Yeah. Now, what we as developers wanted was something else. We wanted to be able to do these implementations really quickly. Because that was arriving all the time. So we wanted to build some kind of framework or way of working where we could do that really easily. But we also wanted to be able to park these implementations really easily. And we didn't want them to pollute our core code base, because if you start extending code and everything is tightly coupled, then some of that code is going to be left over in your core, and that's going to have to be maintained and whatever. So we wanted to limit all that. And we wanted to do it with very, very clean abstractions. But to to counter that pollution, we needed to come up with a better way of doing things than we were doing them at that time. So you're all thinking microservices, right? Well, we're going to park that question for a moment. I'm going to come back to that. But to illustrate why we made the choices that we made, I'm going to have to tell you a little bit about the path that I went through as a developer and that I see a lot of developers go through. Because we developers, we learn from doing things. If you do things, you learn. And you run into a wall, and hopefully you will take something away from running into the wall, and you will not be like a donkey who stubs his foot on the same stone again, but it will learn. And you will do things differently. And that's the only way that you grow as a developer. If I look back at my old code from 7 years ago, or from last year, or maybe even from last week, I wrote some pretty bad code in the past, and I'm hoping that future me will think the same about my code that I write today. Because that means that I learned something and then I became better at what I do. Well, we all started somewhere, and you write your first software product, and you take some blog posts or conference talks or whatever, and you just cram it into a solution and you make something that works. It's the first thing we all did. And then at the moment, sooner rather than later, you get caught in your own spaghetti and become so complex that you can't manage it anymore. And hopefully, you learn. Your big ball of mud or your shit pile or your Demoware or whatever you want to call that, and you make for yourself the conclusion, I can never do this again. Hopefully this happens in university and not in a software project that you have to put live and to production, but hey, you do what you gotta do. So what you start doing is you start doing layers. You think about your UI being on top, your database being on the bottom. You write some data access code and some business logic and some service layer, and you build everything in nice little layers. And every layer consumes the layer below it. Very unlike consuming cake, because there you will consume all the layers at once. That's just yummy. You just want to dive into that. But in your software, you want to keep it nice and tidy. And optionally, you can actually deploy them separately as tiers, and you can put service layers in between and so on. But you will realize after a while that your code is still very tightly coupled. It's very hard to replace stuff, and it's very hard to isolate a feature from this. And your layers grow, and at some point they become unmanageable. And hopefully from running into that wall, you learn again. So you move into learning solid. Somebody tells you about it, or you read about it, and you start applying these principles in your code base. And you have a lot of code reuse in your solid code base, and things are good, and you're applying the patterns. But what you see happen, and I've seen this in more than one code base, so I know that it wasn't just me. I've seen a lot of people do the same thing. It's like what I call layered solid or faux solid or whatever. It's like a hybrid between layers and solid. You write abstractions over abstractions over abstractions over abstractions. You still think of your UI being at the top and your database being at the bottom, and then you have to jump all through all these hoops to get there. And what you will get is a code base. It's working. It's a code base that basically implements all of these for every single thing you do in your UI. And you have a lot of single line calls to the next layer, and that's like a huge mess of classes that you have to maintain that don't do anything. They don't add any value to your code base except making your pattern consistent. And then hopefully at some point it will click and you start doing proper solid. For me it clicked when I realized that interfaces should be owned by the consumers and not by the implementers. And that for me made all the other solid principles fall into place, and I finally understood what that meant. And that's the first time that you can actually easily write your unit tests and your integration tests. And it's the first time that it becomes possible to really do test-driven design and to start doing pair programming and so on. And for me, one of the easiest ways of doing proper solid is to use onion architecture. I'll get back to that in a minute. But this is also where my title for my talk comes from. They're right here, but I took some pictures in my hotel room earlier. If you would have to replace the red tower with the white one, you would need a lot of time. Because I designed this castle so that you would have to deconstruct at least part of the yellow and the blue one. Yeah, because I'm an asshole like that. And it would really be complex to replace that tower with the white one. But if you have to replace the red marbles with the green ones, That's like a 1-minute job, right? You just fish out the red one, you pour in the green ones, and you're done. And that's what good solid code looks like. It doesn't look like a castle, although the name solid claims that it's something rigid, but it really shouldn't be. It should be all this easily replaceable stuff. And when you arrive at this point that you really understand this, then you can start looking at other deployment models. For me, this is something that a lot of people jump in way too early. Like things like doing plugins, doing service-oriented architecture, bus systems, microservices, and so on. Because you will just make another mess of that if you don't understand all the principles that go into these services. I'm paraphrasing Martin Fowler, but he said that the first rule of distributed software is don't distribute. He phrased it differently, but it matched Fight Club, and I like that movie. So microservices. Well, with the team where we were at, our code base was somewhere floating between step 3 and step 4 that we just talked about. Our team didn't have anybody that was senior and that had experience with doing microservices. And we didn't really have a business or performance need to distribute our code base any further. So we decided against that. Because the piece of code that we were going to do the plugins for, it was really all over the place in our solution. So we didn't do microservices, and if you want to take one quote away from me from this talk, it's like never solve a code problem by introducing a deployment problem. Because you're just gonna make life worse for yourself. Because in code you will feel at home. But most of us in infrastructure, not so much. At least me. I don't know about you guys. So the challenges that we had is we wanted to build a flexible application that we could deploy in one deployment. But we wanted to be able to really easily add functionality to it and remove it again. That meant that we would have to be able to add ASP.NET controllers to a central application from a plugin. We also had to have a way to extend all of our core API calls with new derived types. That meant that we also had to get those derived types into our entity framework DB contexts. We had to be able to extend the logic in all the places that we wanted, and we had to have a way to migrate our database. This is all very common stuff. But once you start thinking about plugins, it all comes a little bit harder. So what we ended up doing is we built a proof of concept because one of our developers didn't believe that we could actually on the fly extend entity framework. Best way to get me to do something is tell me it's impossible. I will find a way, trust me. So we did. I built that POC. It was a success, and we started doing this. And this is where my story is going to divert a little bit from reality. Because I wondered what it would look like if we would have to do it in a greenfield project in .NET Core today. How hard would that really be? So I'm going to explain a couple of concepts for you guys, and then I'm going to show you a little bit of code. Trust me, not too much, but to get you on your way if you ever want to try something similar. First thing I want to explain is onion architecture, because that's the core of what I really tried to do. Onion architecture, not the Onion News Network, very funny website, but has nothing to do with onion architecture. Could be that they use it behind the scenes, but I don't know. Jeffrey Palermo came up with the term about 10 years ago, but it's not a new idea. If you think about ports and adapters or hexagon architecture, they're basically all the same thing with a different sauce. But the focus of this concept is to have very clean dependencies and to shield all your abstractions from your core business logic. All with the goal of making your business logic really dependency-free and thus making it really easily testable. So what does it look like if you make a drawing of it? In the center you have your domain model, your classes that you work with. Around that you will write your domain services, which is your business logic. And around that you will write application services, which is basically all the interfaces through which your external integrations can access your core. Because you can only put references to the inside. So your domain model can't reference anything, which makes sense, it's just classes. And your business logic can only reference your domain model, but nothing outside of it. And your application services, they are the ones that are going to expose the logic to the outside world. And everything else is considered an integration. And I see you maybe wonder, what about my UI? What about my database? Because my domain relays on my database. And that's the whole thing that you flip around when you do this. You think of your database and your file system and all the NuGet packages that you use. You think of all those as external integrations. You keep them away from your code, and you write them in the infrastructure part. I hope, no. Yeah, here in the infrastructure part, you will write all your integrations with everything that you use from outside your core. External API calls, all that kind of stuff. Of course, you're going to need a DI container to tie everything together, because otherwise, yeah, you could never run this in runtime. But in build time, there is no references from the core to anything else. There's a lot of benefits to doing this, because the first time you do this, it will maybe feel a little bit counterintuitive. But the cool thing is that no dependencies leak into your core. Because you start by defining that interface inside your core, and then you implement it somewhere in your infrastructure layer, or in your plugin, or whatever. You implement them on the outside, which means there's no entity framework going into your core, or no autofac, or whatever you want to use. And your core becomes extremely reusable, because you can just plug that into a different UI and then just have that reference the core for a change. And this is the cool thing, and that forces you to do really solid, because you have to have these interfaces first, and it makes you think about it. And also, unit testing becomes way more clear if you use Onion architecture, because your core is where your unit tests are going to go. And all your infrastructure code is where your integration tests are going to go. And if you point at your UI or your web service or whatever, because I consider a REST API to be a UI as well, right? The thing is that there you can write your UI tests or your integration tests or your acceptance tests, that kind of stuff. And because all the references are clear and all the dependencies are clear, stuff becomes really easy to mock. Now, the way that I structure it is a little bit more, less of a ball with layers. I do it a little bit more like this, because I don't like my logic being consumed outside of my core. So what I do is I have my contracts that reference my models and my logic that implements those, and then on the outside I only consume the contracts. But it's just potato-potato kind of thing. There's one thing you have to guard at all costs, is that you don't let anything go into your core. So the domain models, the domain services is just the same three things, I just gave them different names. Say for example, you're going to select which DI container you're going to use. And the thing is, you need something from your DI container in your core. For instance, you need a service locator for some reason. I'll tell you later why you're going to need it, because I know it's a pattern that's advised against nowadays, but sometimes you're going to need it when you do this. So you define what you want from your DI container, and you write that interface. You define exactly what you want, and then you're going to, of course, be lazy, because we're all developers. We're going to be lazy. We're going to find a NuGet package that can do that, right? And then the only thing you need to do is implement that interface using your NuGet package. And that will all be very, very short functions. Any of you can do that. It's really trivial. And that's the way that you think about all the external integrations that you're going to do if you do an Onion architecture. And the resulting integrations are really clean. They don't leak into your code core domain. You write them easily, you test them easily, and you replace them easily. And life is peachy. Unicorns, rainbows, the developer is happy. Nobody ever worried why this guy is sitting in the woods without a charger. He cannot work like that for a day. But at least it gets the image across of a happy developer, right? So you're maybe wondering about, okay, all this Onion architecture, very nice, but what about these plugins? Not plugin hybrids. Everybody wants to have a plugin hybrid nowadays. Talking about code plugins. We want them to be easy to develop. Something we can deploy along with our application that enables a bunch of functionality. And if we remove the assembly again, it should just remove that functionality again. It's very simple in concept, but you have to design your core to be able to do that. And we don't want to reference our assemblies, because as soon as we start referencing the plugins, things are going to go bad. And that's why we need rules. Because software development is easy, we like to make things harder for ourselves, right? No, we just want to keep things maintainable for the foreseeable future, at least until we get bored and we move to another project. So the plugins, they can reference the core. They should follow some conventions to make things easy and to not have to write too much plugin code. And we just want to be able to deploy them. They shouldn't break anything if we remove them again. And that's probably the hard thing, because as soon as you deploy a plugin and it does some stuff in your database and you remove it again, you have data that came from a plugin that you no longer use. That's the trickiest part. So let's take a look at what that looks like in detail. Now, I couldn't use the code from the project that I was in at that time. So since we're talking about Lego and about marbles, I wrote some sample code. You can find it all on GitHub. It's on the last slide, so if you want to look it up later, go ahead. I wrote a toy collection API, and it has a plugin for Lego sets, and it has a plugin for marbles. And I had to do a couple of things to make all of this work. Now, the first thing is your DI container, and that's if you're doing both Onion architecture and plugins, is probably the one thing that you really need to work. Because you're going to scan all the DLLs at runtime, and you're going to have to register all the types. And I'm an old-fashioned guy. I don't like auto-wiring any of my dependencies in my DI container. I like to control what lifetime scope they all get. If they are registered as a singleton or a transient or in the request scope. And because I want to control that, I need to, every plugin and every dependency, I need to be able to register its own types in the central DI. But the DI is not in the core, right? Feel where this is going? So at some point, we're going to need an interface that all of the plugins can implement, and where they register their own type in a wrapper that is made for the DI container. Now, before I show you the code, the fact that you're not putting any reference to anything that's outside of your core makes you, if you're using Visual Studio, if you run your web project, it doesn't build all the other stuff along with it. So either you're going to have to make a project where you reference everything that you're working on and throw that away before you check in your code, or you're going to have to hit build manually. I know it's really hard. You have to do an extra click. As a developer, that's like the worst thing in the world. You could do that as well, and then have the CS project just copy its output to the web project, and then you're good to go. That's the approach that I took in my GitHub project. So if you would try to build that, just hit build. Everything will go to the web project, and you can run from there. So for the DI container, I just wrote a simple interface around the type registration stuff, the service collection. And then I'm just going to scan all of the assemblies. And eventually here at the bottom, I will just find all the registrars, and I will create them, and I will run the register services on that. And it's as simple as that. And everybody who implemented, every assembly that implemented that type registrar that I have there, all those types will neatly get registered in my central DI, and we're good to go. Now the hardest part for me, because I don't like doing any kind of front end or UI, and to me ASP.NET Core, it already feels like a UI. So I had to figure out how to get these extra controllers loaded into the central application. Now I wrote this POC originally on classic ASP.NET MVC and not on Core. And there you had to build a custom controller selector and a custom view selector. And then you could load the controllers and the views from your plugins. Now luckily in ASP.NET Core we basically got this stuff for free. You can register application parts. And it's basically as simple as this. If you build a new project, it will basically build one assembly with its controllers and all of its other code, and one with the views. And you can register them both. One you just do with an assembly part, and the other with a compiled Razor assembly part. And that just takes all your stuff into the ASP.NET pipeline. Thank you, Microsoft. Because that took way more code in classic ASP.NET. Now there's one thing that you still have to do. If you use XML to call your services and you're posting a Lego set to a central API, that's really easy. You start with an open tag Lego set and a closing tag Lego set, and your deserializer will know that this is a Lego set and not the superclass toy, although your API call accepts a toy. Now with JSON, your opening tag and your closing tag are just curly braces, so you don't have anything that tells your JSON deserializer what to do. And also when I wrote it back when, we wrote some code around it, but JSON.NET now supports this. It has a if you enable type name handling, blah blah blah, you can basically pass the type that you're posting in a $type property on your JSON object, and then your deserializer will know what to do. Now there are some Stack Overflow articles and blog posts that do this a lot cleaner than this. But if this suffices for you, it takes exactly one line of code to make this work. So I like doing less work, so I took that one. And then if you have to extend logic, you're gonna have to define in your core some interfaces that you can use. And you all know how to define interfaces and consume them with constructor injection, but let's say that your custom logic depends on the type of object that was posted to your API. Yeah, you're only gonna know that type in runtime, so you cannot use constructor injection to get it. And that's why I wrote, remember that I said that I was gonna tell you why you need a service locator, that's why you need it. And this is a pattern that you will have to do from time to time. You have a interface that accepts the superclass toy, and then you create an inherited interface that is generic, and that one actually accepts the subtypes, but that one doesn't have the operation. Why? Because if you resolve this at runtime, resolving a type is one thing. You can just construct a generic type at runtime using reflection. It's really easy. And then you can resolve that in your DI container and get back the implementing class. So that's basically what you see here. I'll get back to the scoped service locator. But here, if I see that my toy is not of the type toy, I might need to run custom logic. So I'm gonna define that toy creator custom logic, the generic one, and I'm gonna construct the type from that, and then resolve that and see if it needs to be run. If you would put a generic operation in the sub interface, basically you would have to find a way to cast the toy, which is still a toy at this point. You will have to cast it here somewhere to the right type, and that's going to give you lots of messy reflection code. So I usually use this pattern with the super and the sub, and it makes the code actually quite easy to understand. Next thing is we wanted to extend our entity framework to understand all these new types that we were introducing in our plugins. We wanted to have inheritance so that if you query all devices, you get the proper types back. Now, entity framework needs three things to work. It needs a model of your code. What do your classes look like? It needs a model of your database. What do your tables look like? And a mapping between those two. Now, we used to write all those things in very messy EDMX files that everybody got lots of merge conflicts on. But luckily, nowadays, we derive most of that information from the structure of our classes and from some mapping code that we write. But entity framework doesn't need all these times at compile time. You can just feed that information at runtime. That's what on-model creating is for. So if you have a plugin that wants to extend the central DB context, we have an interface, I extend toy context, and you just implement that in your plugin and you can access the model builder there. And in your injection code, you're just gonna insert everything. So what does that look like? Here again, I use object instead of model builder. Why? Because otherwise I would have to include entity framework into my core to just make this interface resolvable, and that's not really fun. So in your implementations, you're gonna have to cast, which is really hard to do, right? You have to cast one object to the other, but you know that it's gonna be that type because that's the only thing you ever pass into this interface, so it's gonna be fine. And in our DB context, we just inject an IEnumerable of iExtendToy context. And that's all the plugins that ever implemented this part are going to end up in there, and you can just register them in the onModel creating. Now to get back to this, there's one thing that I told you, that we couldn't break existing code if we remove the plugin. And Entity Framework Core only supports the typer hierarchy inheritance. It means all your fields go into one table. You have one discriminator column that tells you what type of record is in that record. In classic Entity Framework, you could do it a bit more, but in Core, you only have that supported scenario. But the cool thing is that Entity Framework automatically adds a where clause that has all the types that it knows about. So if you remove a plugin and that inherited type removes from your runtime, Entity Framework will actually make a query so that you will not fetch those records from your database. And that's something you get out of the box for free. Thanks again, Microsoft, by the way. It was a lot harder to do before, really. And then the last part. This is the last part, and then I'm going to conclude some things. You can take two approaches to migrating your database. The one thing, there's one approach that you can take, is you take all of your types and you load them all into one central DB context. You take all of your plugins and you generate your migrations based on that. If you're used to working with code-first migrations in Entity Framework, that's the easiest to do, because you can just load everything in and generate your migrations. But then your database will have all the columns, even for all the types that you're not using. But the cool thing is you can run those migrations at deploy time. It will require you to mess a little bit with the migration history table. I'll come back to that in a second. On the other hand, you can take another approach, is that every plugin handles its own migrations. There's also some scenarios where you might want to do that. We ended up using the left one. I'm a fan of the right one, so that's why you get both. The advantage to doing migrations per plugin is that your database structure will always be in sync with the plugins that you have loaded. So that's a very nice thing to have. But it's going to be a little bit trickier to test, because you have to test for every possible combination of plugins that there are no problems there. And it almost requires you to do the migrations at runtime and not at deploy time, because yeah, you don't know which plugins are going to be there. So to go in a little bit of detail for both, Entity Framework Core, I already explained you a little bit. It's a central migration approach. Now by default, Entity Framework Core takes your startup project and builds that. So it also takes your DI from that project. So it loads all the plugins automatically. So it becomes really easy to generate migrations from all of your plugins. There's no code sample because, yeah, it's really textbook Entity Framework Core migrations. The only thing is, as you probably know if you've ever done this, Entity Framework writes to the migration history table. And in that table it also puts its model state. It's the state of your Entity Framework model at the moment that you made that last migration. Now you made that one with all the plugins. So if you remove a plugin, Entity Framework will read that table and look at the last migration and see that there's a mismatch between its model and what is in the migration history table, and that will break. It will just tell you like model has changed since last migration, and it will just refuse service. Like the lazy motherfucker it is. Now there's a very, very, very easy way to do that. If you are running your migrations in deploy time, it's really easy to rename that table to the correct name before you're migrating. Then you migrate, it writes to the table, you rename it to something else again, and then Entity Framework cannot find it. Which means it will run happily, because if the table is not there, it will just assume that the database is in the right state. Excellent. The other scenario, if you want to do your plugins for every, your migrations for every plugin separately, if you are looking for a product that you can use Fluent Migrator. Fluent Migrator is very similar to code first migrations, but it's an independent project. The disadvantage is that you cannot generate them. You will have to hand code them. But that is not as bad as it sounds, because they look like this. It's almost as I think this is probably faster to write than to open SQL Server Management Studio and creating that table there. As a developer, this is really quick to do. So you write your migrations like that. They go separately into every plugin. And the cool thing is, where Entity Framework core migrations really depends on the model state and in the order of all the migrations, this one doesn't care. He's a bit like the honey badger. He doesn't care. All he cares about is about the order of all the migrations. And he just takes the number that you put in the attribute at the top. And if you use a date, you will normally have a logical order. And it will execute the missing ones regardless of the state of your database at that time. So if you've already executed migrations with a higher number and it just finds some with a lower number again, because you load an extra plugin, because that's what you want to do, right? It will just take them and execute them in the correct order. It doesn't care what's already there. Also with this one, you don't have any issues with the model state because it writes to a different version history table that Entity Framework doesn't know about. So if you want to write a migration runner, the only thing that you have to take care of is you have to tell Fluent Migrator about all the DLLs that it needs to read for migrations in one call. It looks like that builder.scan in and then you pass an array of assemblies that you can call that multiple times. Well, you cannot. You have to pass in all the assemblies in one go. So you have to batch your core assemblies and your plugin assemblies in one array and then just pass it. It's the only thing you need to know, and then it works out of the box. So, now that we've got our migrations and our Entity Framework, our ASP.NET, our custom logic and so on, we tackled all of the problems that we wanted to tackle with our plugins. And if I look at my dependency structure of my sample project, it really looks like I hoped. I have my core in the middle, everything references the core and no references go out. And my plugins, they also only reference the core. And the only reference that seems to be a little bit out of place is the one that goes from my UI to my DI project. But that's something you're always going to need. But because at some time during startup, you're going to have to fill up your DI container. There's no way around that. So, to conclude, before you do anything else, structure your code. Make it clean. Plugins are really not that hard to do. We took, what, 6 slides with code on it? Maybe 7? That was all the relevant code. If you take it from my GitHub, you will see that all the code is there. And you can even benefit from my research and just take that if you want to do something like this. And Entity .NET Core took a lot of the work out of our hands because it's a really flexible platform that you can reuse to do this type of stuff. And remember what I said, never solve code problems with deployment problems. And don't worry if you're not in step 4 or 5 or 27. I don't know if there's a step 27. I'm not there yet, but there probably is. Don't worry, we all grew. We all get better every year, and so will you. I have about 10 minutes left, right? More or less. Good. I'll answer the most relevant questions first, and then you can ask me some questions. The first thing is that I get asked a lot, isn't that a lot harder to develop because everything feels counterintuitive? And it really isn't. You have to just try this once. It takes a little bit of setup in the beginning of your project, but you always need to do setup, so that's not really a problem. And from then on, your code becomes just as hard to write as you write it today. It just becomes a lot easier to test and to maintain. Another question I sometimes get is, can the plugins be onions by themselves? And yes, I didn't do this on my GitHub repository because it would vastly complicate the amount of assemblies that we have there, and there's very little code. But you should. If you do this in a real-world scenario, every plugin will probably be 5 or 6 assemblies. It's a very good idea to do the same thing there, and it doesn't make it harder to do. But then every plugin can be its own solution and its own build pipeline. You just package everything with NuGet. It makes your life so much easier. And when should you do these things? Well, onion architecture, there's really no reason not to. If you're developing a new project, try it out. You will see that it's really not as hard as it first seems. Plugins is something else. You have to decide if it's really right for you, because it adds a little bit of friction. So good scenarios to use this is if you need, for some reason, you need modular deployments. You're going to need to deploy a couple of features for some customers and some for others. That's a really nice reason to do plugins. If you easily want to be able to retire code, that's also a very good reason to do plugins. For A/B testing, if you want to test one implementation and another, just write them as two plugins and you can try it out and see how it goes. And also to split up a big software product into a lot of small build pipelines. It also really helps. And the best reason to do this, and that's something that is not in your hands, I'm sorry, but if your business people agree to the 10-100 rule, it's not my invention. I don't know if it's called the 10-100 rule, I just call it that. But it's a concept I once got from Udi Dahan. He said, if you can get your business people to agree that you can write any feature quick and dirty, take about 10% of the effort that you would normally take and you just write it. But then you set a very hard expiration date on that feature. So there is going to be an expiration date where the business people have to decide whether they're either going to throw it away or let you spend 100% of the effort to rewrite it properly. But without this agreement, you should never do this, because you will end up with a code base that is hacks. Don't do that. But if they agree, it's nice. You can create a lot of velocity. You can deliver features really quickly, try them out, see if they work. If they don't, you just throw them away and you invested 10% of the effort. You can try 10 times the amount of things that you could try. But you need a code base that supports that, because you're going to need to throw that code away. Because if you're going to keep supporting that hack code, you're going to make your own life hell, and nobody wants that. Everybody wants to be that happy developer in the woods, right? Good. We're almost coming to the end. When an experienced speaker told me that I shouldn't be saying, are there any questions? I'm going to tell you, ask me some questions. Yes. Yes. It's, yeah, you're talking about doing the migrations, right? If you, the question is, I'm going to rephrase a little bit. If you're running the distributed migrations, you're going to have to do runtime migrations, and you don't always want to have your application in production writing and changing the schema. There is one way around this. You could make a migration runner that takes in a bunch of plugins and does the migration in a deploy time. But then you need to make sure that you run your migrations with the same amount of plugins and with the exact same plugins as the ones that you're going to be using in production. But then you can decouple those two things. You can also, if you use the approach where your application has one central migration, you can generate scripts from them and hand them to your DBA. DBAs love scripts. If you give them that, they will be happy. But that's not as easy to do with Fluent Migrator. It's a lot easier to do with Entity Framework core migrations. More questions? No. The tricky thing there is that once you remove the plugin, the down step of all your migrations is also gone. So you cannot execute the down step because you don't have the code anymore. The thing is that we would either create a manual runner or a manual cleanup at the moment that we decided to retire a plugin. So as I told you, we use the central approach, and the approach that we took is you also make the breakdown script at the same time that you write the plugin. So at the moment that the expiry date comes, or we throw away the plugin, we know what fields we're actually going to have to throw away. Yes. Oh, no, I didn't put it on a slide. But what I do is wait, I have my Visual Studio here. Hold on. But then I'm going to have to duplicate my display. Oh. Wait, I'm just going to move. I'm going to open it and then I'm going to move it over there. A typical type registration. Does it go here? Yeah. So this is a typical implementation. You just implement the interface. You get that iType registration container passed from the startup from your project. And here you just register all the types that are in that plugin or in that dependency, and you will get them like that. And then you can use the per request or singleton or whatever scopes that you want to define for your lifetimes, and you can put those there. Right? We're going to have to close up to give some room to the next speaker. If you want to ask more, I'll be running around. I love talking to other developers. There's 2 more things I want to tell you. First of all, I think it's really awesome that Build Stuff is doing diversity, because we as a software development industry have a problem, because we're mostly like me, white male. It means that most of us have the same blind spots. That means that our industry has blind spots, and we write software for all of society. And that's something. Oh, wait, I have a slide, but it's no, wait. It's gonna be better if I take the correct slide. Like this, right? So be aware of this. Be aware of the fact that there are blind spots in our business. And if you're a team of white guys and you're recruiting a new team member, and you look for somebody that has the same skills as you and the same look at things, you're probably going to end up with another white male. Don't do that. Try to find a person that has added value for your team. Try to find some diversity in your own team, and I assure you that your life will be better. And always respect your fellow developers. Some of them are junior. You're going to have to remember what it was like to be a junior yourself. Life will become easier. I'm Hannes. I'm a .NET consultant. I work for Access. If you want to hit me up on Twitter, that's my Twitter handle. And the slides and the code samples can be found at that URL. Thank you.